And today I will talk about Kata Containers. Before I do that, let me say just a very few words about myself. So I'm Ildiko Bancha. I am Director of Community at the Open Infrastructure Foundation. Before coming to the foundation, I used to work for Ericsson, so I have a little bit of a telecom background, but I was working more on the cloud execution environment side of things, even within Ericsson, so I have a bit of OpenStack background and those kind of things. These days, I focus more on community management, so I am a community manager for, well, drum roll, Kata Containers, as well as the Starting X project. I will be talking about that other one on Saturday, in case you're interested in a distributed cloud platform. But today I will focus on Kata, and for full transparency, I am a community manager, which means that I am not an active developer or user of either of these projects, but I can find you the people who are. So if you have very deep dive development type of questions, I will find you the person who can give you the most detailed answer. So please take me up on that. And also during the talk, after the talk, feel free to come chat about Kata Containers, ask questions. I would love to connect with all of you who are already users, contributors, or interested in becoming one or both of those. So, without further ado, Kata Containers. Kata Containers is an OCI-compatible container runtime, fully open source, and OCI-compatible will become important later. You will see this is, I think, as close as you can get to standardization in the cloud-native container space. So Kata Containers, I think, is a pretty cool project because it kind of creates a fusion between containerization and virtualization technology. And I like to look at it as an evolution path for both. I mean, depend on who you talk to. Sometimes people talk about containers like they are the next evolution step and they are the ones that are, putting VMs out of commission, even though I think containers have been in existence overall just as long as virtual machines have been. So Kata Containers is a great example how you can get the best out of both of these in one simple package, which is a container runtime. Now, why would you even do this? You might ask. So when Kubernetes and containers just kind of burst into the market, everyone got really excited, and you might think that all of a sudden everyone just runs containers everywhere. Now, that is not exactly the case. Like, I remember talking to telecom operators, and it turns out that, yes, they are running containers, but guess what? They are running them in virtual machines. And then you look at public clouds, and yes, they are running containers, but guess what? They are also running them in virtual machines. And then you remember how everyone has been complaining that virtual machines are big, they are heavy, they are slow, a lot of overhead, why do we want them anymore? But it turns out that they are still very useful. So what Kata Containers does is it utilizes the hardware virtualization, but strips down the virtual machine and virtualization layer as much as possible. Like, who needs a floppy disk in the virtual machine anymore? I mean, do you all even know what that is? I remember still, installing Microsoft Windows from 8 floppy disks when I was a kid. It was an interesting experience, but they are just not in use anymore. So you don't need that in a virtual machine either, and along with a lot of things, you just don't need that anymore. But when it comes to that functionality of isolation, now that is something that you need even more than in the past if you think about cybersecurity and how we are living very digital lives, and you have to keep your application, your data, and all your things safe and, well, away from others. So that's what you can do with Kata Containers. And I mentioned already that it is one tiny package, a very compact package. So what Kata Containers is trying to do is really seamlessly integrate into the infrastructure that you are already using. So, kind of not even see that it is there, but it is still making a huge impact. So what it means that I mentioned it's open source, so it's fully available anytime. If you want to grab it, you can look into the source code. If that is something that you are interested in, hopefully you are, you should be able to do so. You can use it with Kubernetes, you can use it with Docker, just like any other container runtime, because even though the container is running in a virtual machine, it actually looks and acts like any other container. And on the virtualization side, you can run it with different hypervisors, so you don't have to be stuck with just one. You have options to choose from, and the same goes for hardware architecture as well. So I mentioned this is pretty cool, but it's actually not that new. The whole idea started when Intel launched the Clear Containers project in 2015. So that was, what, 10 years now? Crazy. And then Kata Containers, the open source project and community, was launched in 2017 from actually two code bases, hyper.sh is runv, and Intel's Clear Containers. And you can see from this little history evolution slide that in just under 1 year, the two communities as well as the two code bases merged. So Kata Containers 1.0 was released and available, already OCI compliant, compatible runtime, and providing you the baseline of this technology solution. And by 2019, companies like Alibaba, Baidu, Huawei, others were running it in production. And what's interesting about some of those company names, like they are in China, which means that if you're having a solution there and deploying it, that infrastructure has to scale to an enormous size, just because, 1.5 billion people, I mean, that's a big number. So those companies really made sure that Kata is tested under load on a high scale in production. And that was, again, 6 years ago. So if you have any doubts whether or not it's ready for prime time, you can be sure it is. It's well tested. And since then, Kata 2.0 started to experiment with Rust, because originally the Kata runtime was implemented in Go, but technology evolves, programming languages evolve. So the community is trying to make sure that the runtime also evolves with the technology and they don't get stuck with one decision just because they made it in the past. So they are slowly but steadily are working on not just having a Rust agent that they had in the 2.0 version, but actually having a full-blown, full-feature parity Rust runtime, which the experimental version is already available in the 3.x release, because the latest release of Kata is 3.14 as of today. So you can already install the experimental Rust runtime and play around with it. It might not have the entire full functionality as the Go runtime does, but it does work. And it is promising even better performance than what the original runtime has been having. And there is a sibling project to Kata Containers, which is called Confidential Containers. I will talk about it just a little bit later, because that kind of gives an additional layer of that security and isolation than what Kata already has through hardware virtualization. And ever since, both the contributor base of the community is growing as well as the user base of the community is growing. So I just threw out a few logos of companies who are using as well as maintaining Kata Containers together. There are even more. So it is just a highlight of the most active contributing organizations. I like to have this slide and these kind of slides because you can see the organizational diversity. So that really shows the trust that companies have in the project who are, again, using this in production and integrating the project into their solutions and products. And what it also tells you It is a great example of a collaborative effort and how these companies are investing in the project. And I would like you to remember the word invest, because open source is great, it's freely available, you download it, you use it, great. Someone else will maintain, not my problem. However, it is kind of your problem if you are using an open source project, deploying it for personal use, production use, part of your products, and especially with new legislations and regulations around the globe, companies are getting held liable for any issues in their solutions and products that they are selling, including software bits and pieces, including the open source bits and pieces in those solutions. So when it comes to investment, that word will really gain new meanings and is gaining new meanings. And when you invest in an open source project upstream, that means that your maintenance cost is actually going down. And this is what all these companies and others as well in the community recognized. So they are already showing a great example, and I'm hoping that I will see all of you in the community very, very soon. So, little technology overview. Scratching the surface most probably, but it is also only a half-an-hour session, so there is no way of going too deep in this amount of time. So as far as the concept is going, it's probably pretty straightforward at this point, and this slide is just explaining to you that containers are great, but when it comes to traditional containers, they're actually not that good at containing. And I stole this line from our general manager, Thierry Carrez. So shout out to him for teaching me this good one. So you can see how through the shared hardware resources and the shared Linux kernel, if you have a little worm in one of the containers, it is really super easy to get into the rest of the containers in that system. Now, it is really annoying to start with, but then it also shows you really well that if that server, that host, was shared between multiple people, this could be in a cloud environment, for example. Like, you have someone else, you don't know them, you don't know if they have bad intentions or not. So if it's that easy to get over to the other container, then would you really want your container to run next to somebody else's that you don't know? Probably not. So this is what Kata Containers helps you with, because again, whatever there's an intent within that virtual machine, they still have a lot of effort to chew through all those layers to get over to the other one. And I did not draw this diagram, so before I move forward, let's see how well you're paying attention. There's a little weirdness on the diagram. Anyone spots it? Yep. It's actually mirrored, so hardware virtualization is written correctly, but I think the letters are just flipped over. I have no idea why. I truly don't know. I will need to figure out who created this diagram, but it just cracked me up when I realized that there's that little mix-up on it. So thank you for paying attention. All right, so, yes?
What does hardware virtualization mean? You virtualize in the virtual machine the software, right?
I mean, you have the hypervisor and the virtualization layer on top of the physical hardware. So it gives you virtual hardware resources like a vCPU. Does that?
Yeah. Since
yeah.
you have another virtual machine on top of it.
I think it's just the way to kind of visualize the hypervisor and that virtualization layer to kind of give an idea that on the left side, I don't know if you see the little hand. So you have the shared hardware resources, and here these are kind of moving over to this hardware virtualization layer, which is written very weirdly. And the virtual machine has its own resources. I mean, it thinks it does. So that's all that it really means. It's just a high-level overview of how virtualization works if you would need to explain it to, I don't know, a 10-year-old probably.
So the container a virtual machine is doing that hardware virtualization, each of the containers.
The virtual machine does. The containers have nothing to do with it. So inside the virtual machine, you have your container, like the namespace and the process. It is the actual container part. And technically, it doesn't really have an idea that it's in a virtual machine. And it shouldn't, really. So the point of it really is that inside the virtual machine, you have the container that acts as a regular container, just like if it was running on the host, on a bare metal server. But you do have, in fact, the light, thin virtualization virtual machine around it. So it is protected through that. And it uses the resources just like in the bare metal case, because it has no idea that these are not the direct hardware access at that point. So on the seamless integration part, I will not spend a lot of time on the slide, but what you can see is, and this is where the OCI compatible runtime part comes into play. Like you can see on the top part of the diagram that you can use Kata containers with both OpenStack as well as Kubernetes. With OpenStack, like you can run it through Docker, and like you run a container with runc as a container runtime. And if you look at the bottom part of the diagram, you can see that the left side of both of these diagrams are technically the same. So the first place where you see a difference is that the runtime is not runc, it is Kata Containers, it's the Kata runtime. But because it is OCI compliant, so the interfaces are implemented accordingly, it just fits into the system just like the other runtime does. And there is the other difference between the two parts of the diagram is, again, that virtual machine. But inside that virtual machine, the container looks and acts just the same. And in Kubernetes world, this all goes through kubelet and through cryo or containerd. You could invoke runc, or you could invoke the Kata runtime. Now, here's the trick. In Kubernetes land and terminology, what you have inside the virtual machine is actually a pod. So I think it's pretty cool. So what it means, hopefully that's the next slide, yes, multi-tenancy. So Kubernetes is a container orchestration system, open source, and it was designed with the goal and intention that you should be able to manage and orchestrate containerized workloads flexibly, easily, all the things. And it does that really well. However, what that also means is Kubernetes was designed with the idea that someone else takes care of the infrastructure for it. So it runs in a cloud platform, again, somebody else takes care of it. So when it comes to things like multi-tenancy, what you need to do with Kubernetes without Kata containers is, you can see on the, I think it's your left side too, on the left side of the diagram, is that if you have an environment that is shared by multiple tenants, like multiple users, customers, then the way to isolate their workloads works by actually running those workloads and those pods on separate nodes. I mean, bulletproof, I will not argue with that. You can still get to those servers through the network if you can manage to do that. But again, other than that, that's the most bulletproof way to implement multi-tenancy with Kubernetes. However, if you think about it, depending on what those workloads are, this can be pretty wasteful from resource usage perspective. Like if those workloads are not really utilizing the entire servers, then why do you really want to run them on 3 different ones? So with Kata containers, because of that additional virtualization layer, you can run all those workloads on the same node. And it creates you the opportunity to have multi-tenancy within Kubernetes, just like if it was designed like that by day one. And I'm not kidding with you. It is documented in the Kubernetes documentation, so you can look it up how to actually make it work in your deployment if you have a deployment already. Another newer concept in Kata Containers is an interface that is available in Kata that is called Remote Hypervisor, or you can also refer to it in Kubernetes land as peer pods, which makes it possible, for example, if you have a cloud and you want to burst it out into, holy moly, I'm running out of time really awfully fast. So you can actually extend your workload out into the public cloud through the remote hypervisor interface. And this is pretty cool. You can see it on the slide that there is a different runtime class. And like you can imagine that the public cloud is maybe AWS, so you can create an EC2 instance, and then when it comes to networking, that goes through a network tunnel to get your Kata pods in the VMs connected to the Kata deployment and the runtime in your current cloud or environment. So it is a pretty cool concept. One thing to note, though, is this is something that you need to implement on the user side. So if you're looking for an implementation of it, the Confidential Containers project does provide one for you. Features, check out the latest version of the documentation. The point of this slide really is that it gives you networking, storage, and all the things that you would expect from a container to be able to give to you. And the community is also working on, adding more hardware support. So GPUs and things are also supported in Kata Containers. Just think back the slide with the logos and NVIDIA for a good example of all that. And I think I have roughly 3-ish minutes left. So one thing I would like to mention about releases, without going into details of what's inside Kata 3.x these days, is that Kata has the community came up with a simplified release process, which means that they are putting out a minor release every single month. They don't have a stable branch for those minor releases anymore. So if you want bug fixes, if you want any enhancement on any feature, then you have to use, download, deploy the latest and greatest. So please make sure that you are running that, because there is no stable branch that gets, bug fixes backported. So that concept really goes more for the major releases, which is planned, 4.0 is planned for 2025, and the really big item should be and will be the Rust runtime available with full functionality, same as the Go runtime. And in 4.0, the Rust runtime will be the default one, and the Go runtime will be deprecated. So that will be the biggest change once 4.0 kicks in. You can run Kata on bare metal, you can run Kata in the cloud, and as you can see, the hardware diversity is also there, Intel, AMD, ARM. Whichever you favor, you should be able to run Kata Containers on top of it. And I will give you a little glance into Confidential Containers, and then I will probably end there, and then I will be only like 30 seconds to a minute over. So Confidential Containers is a sibling project to Kata. The two projects share a good chunk of the contributors. Many people are involved in both. Confidential Containers has the mission to bring confidential computing methods and techniques into the cloud-native space. So think about things like trusted execution environment. So when it comes to isolation, it is actually in the hardware. So think about the main CPU unit, which protects data as well as your application code that it is executing at any given time. This does require hardware support, so you need hardware that implements confidential computing techniques and provides the trusted execution environment support. And you also need software for that. And if you remember those two diagrams with like how to integrate and enable startup Kata in like OpenStack and Kubernetes environments, you can see on the left side here again, kubelet, containerd, Kata runtime. This is how it all starts. And you can see how confidential containers does have the implementation of peer pods. So what it means that Kata Containers is the vessel to be able to use confidential containers. So if you are interested in this technology, then you will need to use the two projects together. They are closely integrated. And based on my interaction with users, you really can't find this technology and this combination anywhere else in the market. And this is all open source, both Kata and confidential containers, Apache 2 license. So you have access to the code, but even more importantly, you have access to the communities. So I would encourage you to reach out to me if you need guidance on how to reach out to the two communities, or look them up online, join the team meetings. Both communities are on Slack. Kata has their own workspace, Slack workspace. Confidential containers are in the CNCF Slack workspace. So reach out to the communities, work with them, fill out the user survey if you're already using the project, and make sure to give feedback, report a bug if you find it. If you fix it, it's even better. So make sure that if you become a user, you also invest in maintaining the project upstream, because that's what will guarantee your success, the project's success, and its sustainability. And with that, I will stop here.